Hey friends, did you know that Azure Cosmos DB handles over 11 billion transactions daily for ChatGPT? That is spread across more than 40,000 physical partitions. Massive scale and a flexible schema is what makes Azure Cosmos DB such a robust NoSQL database. Richa Gaur is here to show me how to maximize availability and performance as my app grows today on Azure Friday. Hey friends, I'm Scott Hanselman and it's Azure Friday. I'm here with Richa Gaur. We're going to learn all about Azure Cosmos DB. How are you?
Hi, Scott. Thanks for the introduction. I'm good. How are you doing?
I am very well. I am always excited to talk to people from the Azure Cosmos DB team. You're doing amazing stuff over there. It is such a fantastic database. I had no idea that it was part of what was behind ChatGPT and was doing such huge scale and so many 11 billion transactions a day. That's insane.
Yeah, that's correct. It's amazing how it scales automatically and is able to power ChatGPT for
Yeah.
daily 11 billion transactions. Yes.
So you've got a bunch of different capabilities that you want to show me, and you brought me a live demo that's going to show me how it's going to make me a better developer and a more productive developer, right?
Yeah, that's correct. I wanted to showcase some capabilities which will enhance the developer productivity and also increase the efficiency of the application at the same time. So, yeah. Uh,
All right, let's do it. I want to see this.
Sure. Let me share my screen. Yeah. So today we are building an energy optimization solution which will help enterprises reduce their energy emission and reach their energy emission goals because sustainability is what we are looking to forward in the future. So with that, let me start by building the application. I will set up my database first. So I'm creating an Azure Cosmos DB NoSQL API account. So I have some of the information pre-filled like resource group, account name, etc. Coming to capacity mode, there are two capacity mode that Cosmos DB provides, serverless and provision throughput. Serverless is with serverless basically you don't have to provision any capacity, you don't have to do any estimation, and you will only be billed for the capacity that you are using to execute the request. While with provision throughput you have to uh, estimate the capacity, and with that you will get guaranteed performance and predictable billing. So both of these options are possible, but since I'm new to Cosmos DB and I'm building the application, I really don't want to deal with the capacity estimation at the moment. And I really want to focus on building the application first. So I'm going to go ahead and select serverless for my application and create the account. So I already have an account created for my database, and this is how my schema looks like for the energy consumption and usage for the individual devices within an organization. Here I've chosen org as the partition key because most of my queries are going to be executed within an org, because I want to see the energy consumption for org and individual devices consumption within that organization. So yeah, with that, we are ready to deploy our application. So let's move on to the EnergyWise Solutions platform. So this is what my platform looks like. And I have the daily energy consumption for 24 by 7 AI, which is one of the earlier organizations that have onboarded onto our platform. And this is their daily energy consumption. So with this, we can help them optimize their energy consumption, and they can detect any anomalies if there is more than usual energy consumption. And in order to help them do that, we also have device energy consumption, so we can see individual device level daily energy consumption and figure out any anomalies if that are there.
And when you're doing IoT solutions like this, you have a huge amount of data happening because you've got maybe data every few minutes times this many devices. That's why Cosmos DB is really great for IoT solutions because you have large amounts of data over time, and it turns into a huge amount of information.
Yeah, that's correct. Now that we are we have launched our application, and it's really successful for the organizations that have onboarded to us.
Hmm.
Some larger organizations like Microsoft has decided to onboard to our platform. So yeah, it's a huge win. But with this, we have a problem, because for a large organizations like Microsoft, the data is going to be huge, and which will hit our 20 GB partition key size limit very easily, and very soon enough. So in order to onboard them to our platform, we'll need to reshuffle our schema and change the partition key. Luckily for us, this is a very common scenario for Cosmos DB customers, where when they start with certain partition key, and as their application evolve over time and the use cases change, the original partition key is no longer efficient for the new set of queries that they want to run. So, in order to solve that particular problem, Cosmos DB has come up with a partition key change feature. So you just go to the settings tab in your data explorer and click on partition key tab. And here is the option to change partition key. So I'm going to go ahead and change the partition key of my container. So I'll create a new container because the data needs to be copied to a new container with the new partition key. So in this scenario, I'll create a hierarchical partition key because I still need to query with org and as well as the device ID. So this will help me go beyond the 20 GB size limit for a single org, and as well as direct my queries towards a subset of physical partitions in case of org, and a subset and a single partition in case of a single device.
So does,
So
does does smart and hierarchical partitioning like this was what allows you to effectively scale infinitely?
yeah, that's true. So basically, this gives me the limit of having 20 GB data size, which is huge for a single device over time. And not only this, I can have a third level of partition, hierarchical partition key as well. So if my data grows beyond that, or if there is any other use case that I want to cater to, I can add a third level of partition key as well.
Wow. Okay. So if one device theoretically were going to go and make more than 20 GB over a long period of time, you could then have sub partitions in that hierarchy, which again effectively gives you unlimited ability.
Yes, that's correct. Having said that, I just wanted to highlight one scenario. So in cases your data is like very skewed for a particular tenant, like a single or tenant is occupying a huge subset of your data, and a lot of queries are coming to the subset, it's advisable that you isolate that particular tenant to a different container altogether, because in this case your data will not be like equally distributed, or your request volume will not be equally distributed, which will not be efficient, and will not be able to you will not be able to utilize the throughput that is available for your container. So as long as your data distribution is homogeneous and not heavily skewed towards one container, it's one tenant, sorry. So it's hierarchical partition key are going to work fine. But if that the previous scenario is there, that your data is very heavily skewed towards one container, it is advisable that you move to a new container altogether.
That makes sense.
So yeah. So with this, we have like our partition key change job is running. So what happens in the background is with this, we have created a new container, and then the container copy job will start. So in this case, the job is in progress. So what that container copy job is a in-house capability that we have developed for internal migration from one container to another container. So this will in turn spawn up two compute V2 processes in order to do the copy from source to destination container. And once the copy process is complete, we can go ahead and change the container in our application. And if there is a partition key change, that we can do that as well. And our application is ready to, take advantage of the new partition key. Yeah. although this process looks simple and neat, this is an offline process, which means that applications which are mission critical are currently in production. This is not going to work well. To offer this same functionality for those customers, we have come up with online change partition key process as well. So while this is happening, let me quickly show you a demo of that as well. So I'm going to use Azure CLI commands.
All right, so I see your command line.
Yeah, so I'll be using Azure CLI commands to run the online container copy process. I'm just setting up some variables like source container, destination container, etc. Then I'll create the online container copy job. So this is very similar as the offline container copy process. The only thing is that we are providing mode as online, which means that with this process, your source container can continue to receive updates, and your business application can run as usual while the data copy process is running in the background. So there is effectively very no downtime involved during the data copy process. And once your data copy is complete, you can check that with the monitoring API that we have.
And is it going to take care of all that work for me in the sense of it's effectively bringing up a new container, draining connections off of the old container, bringing them up, and then keeping a log of what's changed so that the change management's happening and I don't have to think about anything. You're doing all that work for me in the background.
Yeah, so as far as change management is going, that is being taken care of. So as your new updates are coming, those are being copied to the destination container while the copy is in progress. But in this scenario, since it's a command line process, you have to create the destination container first and then do the start the copy. And once your data copy is complete, you can see from the status API here with what's the process count. So once that is done, you can effectively, you'll have to call the completion API in the scenario, because since this is a live copy, we cannot know whether your copy is complete. So you'll have to call the completion API in the scenario in order to do the cutover from your application to the new container. So I'll just show you how to call the completion API. So this is the completion API. It will mark the job as complete. It will drain any remaining changes. If there are any remaining changes, it will drain them and deallocate the resources which have been allocated to do the copy process. And with this, you can cut over your application to the new container. So effectively, there is very minimal downtime involved in this entire process, depending on how your cutover process looks like.
Very cool. Very cool. And then I understand also that even though you started this entire project in serverless mode, this feature worked in serverless mode, and you could theoretically then change to provisioned output as well. And those partitions, everything is going to remain. You're just going to improve your throughput if you switch to provisioned.
Yeah, that's correct. So in our scenario, let me just share my screen. Yeah, that's very correct. So if you need to like build highly resilient and available applications, you will need to switch to provision mode, because given the nature of serverless, there is no guaranteed performance. And since it is single region, so in case regional outages happen, your application will face downtime. So since we don't want that, we would switch to provision throughput in order to build highly resilient and highly available system in this scenario. So since we have also started to build the alerting mechanism, which will alert the enterprises in real time for their energy breaches. So in order to do that, we'll need certain level of guarantee from the database so that it remains highly available and provides a certain guarantee of performance at all times. So we'll go ahead and move to provision throughput in the to provide those guarantees to our customers. So I'll just go ahead and click on change capacity mode to provision throughput. So as you can see, the current capacity mode is serverless. I'll go ahead and click on confirm here. This will basically effectively uh, change your capacity mode from serverless to provision. This will take some time, but while the migration is in progress, you can continue using your container as usual. You can read, write, and query your data as usual, and your business won't be affected. And your capacity mode will be changed to provision throughput in the background.
Mhm.
Uh, but you cannot perform any management operations during the migration process because the capacity mode is being changed, which is understandable. So yeah, with that you will have a provision throughput account with effectively no changes in your application, because your application will continue to run as usual, and you will have the highly available guaranteed performance of P99 SLAs at with 10 milliseconds latency. So with that, we have our highly available and highly performant database and application. Yeah.
There we go. Look at that. Okay, so it's switched itself to provision throughput. You've opted out of the free tier discount, and we've switched this now from capacity mode serverless to capacity mode provision throughput.
Yeah, that's right. And your application can continue to work as usual. You don't need to make any changes in the connection endpoint or the container name or anything as such. And you can, take advantage of provision throughput guarantees.
Very cool. And then, of course, switching to provision throughput is going to give me that high availability. It's going to give me the robustness, and then guaranteed, and that's the most important thing, guaranteed latency, right?
Yes, we have P99 SLAs for latency as well as availability. For latency, you get P99 request completion within 10 milliseconds for both read and write in with direct connectivity mode. And we have 5 nines of availability, guaranteed availability with 2 or more regions. So yeah,
Very cool. Well, thank you so much for sharing this with us today.
yeah. Thanks, Scott, for having me.
All right. I've been learning all about how to maximize availability and performance as my Cosmos DB app grows today on Azure Friday. Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.